record. Hey, how about that? And I'll just leave you up this time. So, hope everybody's doing well. I went outside this morning and it feels like it's summer already. This weather is incredible. I'm seeing patches of grass in my backyard. Um, so, as a bit of an organizational note, I will put up a small homework assignment probably later today. Just want to make sure that I format it because last year I structured the class a little bit differently, or last semester, I guess, and I don't want to make your exam preparations a horrible pain. So it'll be a little bit smaller. Basically, I'm going to break up one assignment into two chunks, and it will be individually driven. Um, don't forget to, now that that homework was done, the last one where you got everything set up with your repos, start meeting as your project team um, once per week, and make sure you do a push to your meeting minutes folder. So if you, um, there you go. If you remember, go into your team project repo, there's this meetings folder. Make sure that once a week you check in a new document with this meeting minutes template. So what's your team name? Who was there? When was the meeting held? What time was it? What did you talk about? What are your goals for next week? Make sure that you actually spend a few minutes to do this once a week so that your team can all be on the same page, that somebody's not left out of the plan, that everybody knows kind of what we're doing going forward, um, and get started. And these early meetings, honestly, since we're just getting going, probably good to talk about ideas, maybe initial responsibilities, things you want to explore, um, things of that nature. And while you're doing that, I obviously I haven't given you feedback yet on your project proposals, but kind of assume that that's the direction you will go in, unless if you've given me options to weigh, I guess. My goal as the person grading them is to give you feedback and to scope them, not to say this idea is bad. It's to encourage you and say, maybe do a little bit more of this, do a little bit less of this, but I'm sure based on what I've seen so far, they're probably going to be okay. But don't forget about that because the number of meeting minutes you check in are going to basically be a part of your term project grade. So don't forget to do that. Other thing, if you are in Blackboard, you might notice that this exams link has appeared on the side menu. Let me make this a little bit bigger. There's a blank spot before. This is where the midterm review guide is. Now, I've got a bunch of questions on here for you, and I'm not sure why Blackboard's doing this weird formatting thing with bullets and enumerations. It's very bizarre why it's doing that. But here is basically a list of questions that I'm going to draw from for the exam. I will, of course, I'll modify them slightly, but the gist will be basically what you're seeing here. I'm not going to put all of them on your exam. It'll be structured for a 1 hour exam slot. So it's not like, it's going to be a 5 hour exam for you. But that is there for you to start reading over and start getting prepared for. Again, I'm not going to give you these exact questions more than likely. I'll probably modify them so that they're different, but the ideas will be the same, right? And the other thing too is I've got a little note here for you. A couple of things. March 3rd, right? Yeah, so it's next Wednesday, I believe. Yeah, the 3rd. One of the students in my other class, their midterm falls right on his birthday, so it was a delightful birthday present for him. So the format's going to be mainly like short answer type of questions, things that I'm going to ask you to actually write a response to, not just A, B, C, or D. It's on the internet. I am not monitoring you. We're not using a lockdown browser or anything like that. But in return for that kind of, not niceness, because I think the lockdown browsers are terrible in and of their own right, But just be honest with your exam, right? Don't cheat, don't plagiarize. If you are pulling information from the internet, let me know where you got it from and how you're distilling it, that kind of a thing, in return for that trust. Yes. Again, I consider you all adults until you prove me otherwise. But I know it's a stressful time. I know it's going to be um, hard for everybody. So just try to do your best, basically, is what I'm looking for. I have gone down the path of academic dishonesty, and the reason why I've got this big paragraph here and why there's a massive chunk of it in the syllabus is that I have had students in the past where they did plagiarize, they did cheat, and it was just awful for everybody, me included. I don't like doing it. Students didn't like doing it. It would have just been easier to do the exam. Um, but the same note, if you are going to do that, I'm not going to feel bad if I catch you, right? It's decisions everybody's making here. So just feel free to go through these. We will do a short review on Monday. Not going to take the whole class, but I'll basically ask you if anybody has any open questions. Maybe I'll ask a few, see if anybody actually checked it out. But any questions on what I'm looking for so far? This is mainly for your benefit. I've got a section here at the bottom on UML models. I don't know how far we're going to get this week. So if we get to UML, I'll probably put a UML question on there. If we don't get to it before Wednesday, then there won't be any UML on it. But we should at least get through basic requirements here. Will this be synchronous or asynchronous? Good question. This will be asynchronous. So Wednesday we will not have class next week. I'll put out an announcement with the structure and all that as well. But as the preview, I will open the exam on midnight of the 3rd. I will close it on midnight, basically 24 hours later. So you will have the full day to do the exam. I'm not going to look at when you started versus when you finished, as long as it is done by the end of March 3rd. I'm happy. So you can open it at midnight, close it at 11:59, and it's okay. It should take an hour, so if you do it during class time, then, I mean, then you're done for the day. For me, anyway. Don't know what else you have going on. Yep, anytime. Like I said, just do your best. It's not going to be hard if you've been keeping up with the material. I guess not hard, but the questions are not necessarily going to be anything tricky. It's everything that we've covered and that we've talked about. So if you've been keeping up with the slides and the videos, you should be fine. All right, so is that all I wanted to talk about? Yeah. So I will also, again, I'll send out an announcement for the structure of this. I will send out a short homework assignment on writing requirements later today. And that will be pretty much it until after the exam. New follower. Neato. 1 second here. Let's get something I have to pull up on my other screen. All right, just in case. Will we be able to use class notes for it? Yes, so again, I'm not going to watch what's happening on your screen. I'm not having you turn your cameras on or anything like that. Use whatever you'd like. Pretend it is an open book exam, basically. And you could take that as a positive or a negative. If it's open book, that means usually we make it harder, right? The questions are going to be structured so that you have to think through them. It's not, hopefully not going to be a rote response type of thing. Anything else? I guess I know a lot of professors have different perspectives on how to run online exams. I looked through all the options. I wasn't comfortable with lockdown or any kind of remote proctoring. So this is how we're going to do it. Hope it works out okay. Anyway, enough about the exam. We will talk about it on Monday. Unless if you have any questions, feel free to pop those through the chat. I'm happy to answer them if you have them. This is about where we ended up last time, right? So we were talking about user groups and creating requirements based on who is going to be using our software, who is going to be using our actual projects, right? And we are basically trying to figure out what's their level of technical expertise, how often are they going to use the product, are they power users, are they computer illiterate, are they going to have special access rights? So all these things will filter into your requirements. Excuse me. Now, when we have requirements that we're developing and we have all of these people, they may have differing opinions, right? And this is where we ended up. And I talked about having conflicts, and how we resolve conflicts is going to be key to your job as a either requirements analyst or a software engineer who has been forced to handle requirements elicitation. So question for you, what do you think some examples of requirements that are conflicting would be? So these would be things where person A wants one thing, person B wants another thing, and to implement person A's goals, person B's requirements would not be able to be satisfied. So what do you think a conflicting requirement would be? So I wait for some of these to filter in. Yes, to class notes. Also, I wave to everybody here. Security and ease of use. Ooh, that's a good one. We want this thing to be very, very secure, but we want it to be easy to use. Yeah, I could see that one, because if you have stringent security requirements, you're probably going to have many hoops for the person to jump through to actually use the thing, and then it's no longer easy to use. Absolutely. What else do we have? There's a great example. I don't know if any of you use the VPN from home at the school, but in order to log in, you need to download, or at least for me, it's Pulse Secure. I'm not sure if what the Mac software is, but you need to do that. Enter your username and password, and then you have to go through and download a secondary application which has it's the Duo, like it's like an Authy type of thing, where it has a one-time rotating code. So you have to go open up an app, check that code, enter it into the VPN software, and then hopefully you're online. Very annoying, but a lot more secure than it was before. Functionality and ease of use. Okay, so if we want to provide lots of different key functionalities for our software, that might make it a little bit more complicated. Imagine, actually here, while I wait for that to, if anybody has any, sorry, want that to still be on the screen. Anybody has any others? Speed and not sure what conflicts with this memory. Yeah, that actually is a good one. I'm just pulling up a Google image here. Complicated GUI. Yeah, here we go. Open image in new tab. Thank you. So here would be lots of functionality, but not very easy to use. This looks like your typical internal engineering software application. I mean, how the heck do you figure out how to use something like this? Regardless if it's got the Windows 98 style of GUI buttons. But yeah, so speed and memory, absolutely. If you want to speed things up in terms of your software, load it all into RAM, right? Things that are in RAM will run a lot quicker rather than pulling it off the hard drive or reaching out to a database or something like that. But the cost of that is that your memory gets taken over and then the rest of the system can't really do anything until that RAM is released. Money versus user satisfaction, a lot of options and simple layouts. Yep, so that kind of goes with functionality. So yeah, definitely all good answers here. So you can kind of hopefully see what we've got going on. Just trying to see if I had any other good examples for you. Finishing the complete project and time constraints, absolutely. Timing. So do you want everything done correctly, or do you want it out on time? This is actually a great kind of segue into project management discussions, because at the very beginning of a project, typically you will set up a project timeline. just something that you're all going to be doing in class in the near future, honestly. But you kind of figure out what your milestones are for your project, what features you have to finish at such and such a time. And if you break away from that timeline, it can be impacting your budget, your schedule, your public goodwill. Um, these are all things that we have to deal with, accessibility and security. Yep, so that goes hand in hand with one of the other ones, security and ease of use. So all very good examples of conflicts. And how we handle them again, let me go back here. These are all things that we need, right? It's not like we can say, okay, well, screw the users, let's make sure we put out a perfect product. That might be more desirable because then we can actually put out something that's good. But if we're going to delay a games by, say, a year, maybe all of our public goodwill dries up and then nobody buys the game. See Duke Nukem Forever, which turned out not to be a very good game anyway. But basically, how do you manage this as a software engineer, as a project manager? Figure out what is absolutely essential. Okay, so look at these options that you gave me here. Finishing the complete project and time constraints. Okay, games, maybe they're a bad example here because there's a lot of marketing and a lot of entitled users out there too. But if you miss your target deadline by a month or two, and if that you can take that time to polish your game, who cares? But what if it is a component for an aircraft carrier, or if it's a component for an automobile? And by you not finishing your radar system, your LiDAR, whatever it is, the entire production line gets pushed back, and the company loses millions to billions of dollars per day of units they can't ship. So there's lots of issues to deal with here. But one of these, security versus accessibility. I mean, accessibility is desirable, but it's not absolutely essential if we have data that needs to be secured. You don't want your social security number to be leaked or your credit card to be leaked just because your software is a little bit easier to use. But hopefully you can see the difficulties here. This field of software engineering, again, it is a field of trade-offs. Which one do you pick? Okay. So let's now pivot towards another role, the product champion. Now, this is going to be usually somebody within your company where their name's going to be tagged to the project, so they are the product champion. Basically, these people are considered to be the voice of the customer, but they're trying to be representative of their needs and their desires. So basically, if you are the project champion or product champion, you are talking to the requirements analysts, you're talking to the engineers. You could be an engineer yourself. More likely, you're probably somebody higher up in the organization at this point. But you're kind of the one driving this product in the direction it needs to go. With that, your name is on the project as champion, right? The idea here is that this role is basically very impactful on how the requirements kind of work out in the end, right? They maybe help resolve these conflicts. They help to push the direction of the project, hopefully based on either a certain user class or a list of user class, or a list of user class, a type of user class. Um, Sometimes annoying to deal with if you're an engineer, but definitely beneficial. So let's say that we have a whole bunch of conflicting requirements, and then you have this product champion pushing a certain set of requirements in the direction of the user. Are there any issues that you could see here with the champion? So basically, you have your requirements analyst who's trying to figure everything out to make everybody happy. You have your engineers who are haranguing you for, okay, we need requirements, we can't do this, we can't do that. And then you have this other side. You have a high-level manager, maybe a business manager, maybe a division head or something like that. This person is the product champion, and they want it to be accessible, they want it to be pretty, and they want it to be fast. What are the issues that this person can bring to the project? And when I say issues, it's just things you have to deal with. It's not bad, it's not good. I mean, if it was bad, we wouldn't have this role, right? It's a necessary role. Did I do my ordinary sausage bang on the table good enough there so that the camera went all fuzzy and out of focus? Unrealistic goals. Oh my God, phone, stop buzzing. I swear there's like a natural disaster happening here. Mute. Unrealistic goals. So that is a good one. This person is representing, say, a class of users, and it is completely infeasible that they can't meet these goals, right? Accessibility over security. Okay, yes, it has to be secure. Everybody's agreeing it has to be secure, but this champion wants it to be pretty and easy to use, and a one-click mobile app where you don't have to log in or something like that, right? Unrealistic. Um, they could try to push their agenda for a project and try to take it in a different direction that everybody else has agreed on. And depending on their role within the company, right? If they're a champion, they're supporting this project, but maybe they're higher up, and then you start feeling, and this is like one of those soft personal skills thing. Maybe this person, by merit of having a higher role in the company, you should listen to them more than your security analysts or your software engineers, right? Because this person, I don't know, has a more power in the company. That could be a trap that you could fall into. And some of them appreciate pushback, some don't. It's just something you may have to deal with in the future. It goes kind of towards that ethical stuff we talked about at the beginning, too. You could have a stubborn and strict champion that is hard to work around. Yes, that is another thing, too. Absolutely. Kind of goes hand in hand with unrealistic goals as well, right? So they put a goal forward and they never want to budge, they never want to compromise. Not necessarily strictly to the product champion. Again, any stakeholder could be like that too, right? So, good stuff. Just be aware. And I'm not trying to say it's going to be the worst thing in the world to work with a product champion. Again, they're there for a reason. But some of those interpersonal skills that you're kind of developing right now, make the best use of them. If you get into not necessarily an adversarial relationship, but if you need to hold your ground, don't feel bad about having to do that. Use your ethical background as a solid wall behind you. Okay, so we have our analysts, we have our champions. Let's talk about a requirements spec, because we're going to assume that we have, the other stakeholders that we have on our project will also have an impact here. So everything that we've done in terms of analysis, in terms of elicitation, we are going to put it in our software requirements spec. And again, this is the deliverable that you're going to do for the end of the semester as part of your project. It'll be a markdown document too. Now, this SRS is going to have, and we looked at the table of contents before a little bit, right, for one of them, but you care about system features. So basically, what is this thing doing at a high level? So maybe your design decisions could be talking about an architecture of your project. Basically, we're going to have different levels of granularity specified in this document that we're creating. We'll have external interface requirements. So if this thing has a public-facing API, or if it needs to reach out to other applications or reach out to cloud services, other modules, how do we interface with them? Right? What are the exact requirements of this project to function correctly? We're going to have our functionals and our non-functionals. Hopefully those are relatively clear right now for you. If not, you'll be getting some practice on them very soon. Again, functional are going to be very easy to quantify, very technical, very specific sentences. Generally, you want like one sentence per requirement is about all you need. Maybe two, but then you're getting a little bit wordy. Again, zero ambiguity in those. Non-functionals are going to be more high level. They'll probably impact the whole project. There are going to be your ilities that are the fluffy, make your project good and secure and pretty and things of that nature. Also have your user classification, so who are your target user groups, right? Is this for gamers? Is this for people who are mobile users? Is this for, um, is this an ERP system for a company? So we're expecting HR people to be working with this. Enterprise resource planning is ERP. It's like your salary, your project planning. It's a big thing in the industry. Kind of like shores up a company's back end there. Basically, who's going to be using it? And then we can also have more in here as well as needed. But let's say we have this SRS put together, okay? You've gone through elicitation. We are agreeing that we have all the things that we need to have in there, right? All of these headings, we filled them out. Now we have to go ahead and actually validate our document. And this is interesting to talk about because it's not like we're performing software testing here where you have a test that passes or fails. Validation is actually reading your document. Consider it kind of like an editing pass in a way. So you're going to check to make sure that all of your requirements, A, are correct with respect to the product that you're building, B, that it's actually what the customer wants and that you haven't misinterpreted something, um, and then C, that it's actually correct. So I've got a list of words here, like kind of a list of adjectives for you that requirements should be. So they should be correct. What does it mean to be correct? If I have a requirement that specifies the voltage range of a particular piece of hardware in my system, and I keep calling out hardware voltage ranges because, again, we can have hardware specs in here too if we're building an embedded system, right? I have a heartbeat sensor. Maybe I'm building a smartwatch. Okay, this sensor needs to be fed 3.3 volts by our main piece of equipment we're using. And if for whatever reason we don't have the hardware in place to step down like a 5 volt to a 3.3 volt, it will fry the circuit board. Okay, so that would be a good requirement. Correct would mean that we didn't make a typo, that we didn't actually put 12 volts by accident. And then if we actually follow through with that and we feed this in 12 volts, we see all the magic smoke go up in the air, and it doesn't work. Basically, the thing with requirements specs is they are a written document, meaning that we as humans will probably make mistakes in writing them. So it's just like any homework assignment, every paper you've ever written, take the time to read through it before you submit it because you can catch like silly mistakes that you've made. Maybe you're really tired. Maybe you were over caffeinated. Maybe you were not paying attention because you were excited to go outside and play in the snow. Or, whatever happened, it's possible to screw up. We just have to make sure that we fix them. Another thing here too is that they have to be consistent. So if I have an entire section detailing the security features of the application, right, we should be using SHA-512 encoding or encryption for our data. If we then have a decryption section later on that talks about the blowfish decryption, that's not going to match up with our encryption algorithm, and we're just going to get garbage out. Basically, you have to make sure that they're consistent through this massive document, that you don't have any like conflicts that are unintentionally harming your system. This is an entire field of software engineering too, where you can have, say, feature interactions. And since we have a moment here, what's a feature interaction? This is a unintentional conflict as a result of your requirements. Great example from a older Ford car. Trying to remember what the exact example was, but if any of you have ever worked in an automobile company, there or know anything about modding cars or anything like that, there is a network inside your car called a CAN bus, and it's a very, very simplistic networking protocol. All of the components that are computer-based can basically talk to this bus and pass information around. Pretty easy, very low in terms of security requirements and all that. Well, on one of these vehicles, now I can never remember what the exact order of operations was, but I'm pretty sure that if you pushed the window button to have the window go down, it would turn on the windshield wipers. It was either that or you turn the radio on and the windshield wipers go on, one of those two. But basically, a direct action that you specify for one system also impacts another system. And there are basically conflicting requirements, inconsistent requirements in your document. Okay, module A, say it's the windshield wiper module, it's expecting data from the bus in a certain format. Module B, I said window, the windshield wiper component. Again, this is just a computer controlled thing these days. It's also expecting data in that same format. This bus is not very secure. The data is just left on the bus for now. Both these components pick it up. Both things happen at the same time. Not necessarily a good thing, but an inconsistent requirement, a feature interaction that happens. Kind of cute to talk about, but what if it was something a little bit more critical, like a brake controller or um, something mixing the gas ratio in the engine? Okay, these things can be a little bit worse. All right, other things here. They should be unambiguous, they should be testable. Basically, there should be nothing that is unclear in your requirements. The programmers, the entire project team should know exactly what you're doing with these things. They should be feasible, meaning you shouldn't write something that is completely impossible to program in here or impossible to develop. I'm not going to go through every one of these, but one of the interesting ones is that they should also be traceable. This is something that we're going to be getting into here momentarily, but a traceable requirement means that you basically have, and this is going to go to that type of configuration management system type stuff. Again, we have like a requirements management system that we have for these things. I'll show you some examples here momentarily. But if you have a requirement, it's going to be an object in one of these tools. It's not just like a Word document type of thing. Okay, I enter a requirement in, I'm going to link it to several test cases. I'm going to link this requirement to lines of code in my application. I will link it to design decisions in my higher level documents, to early on vision statements or something of that nature. Basically, what we're doing in terms of traceability, I don't know why I did that in quotes because it's an actual term, we're making sure that this requirement is satisfied, that it matches exactly what we want to do, and that we can show an entire auditing trail for every single requirement that it is being met and satisfied. And I know somebody mentioned this last time too about, making sure requirements are met. This is what traceability gets us, right? Finally remembered to mute so you don't have to hear my awful coughing. Okay, so this is basically what, right click, not left click. This is basically what validation is getting us, right? We need to prove all of these things. Very important for if external auditors come in as well. They will check over your requirements and make sure that they're clear. So that's another thing we have to do. How do we validate? Well, we can do reviews. So let's get everybody in a room together, prepare them. Here's all the requirements documents. Come into this meeting with your thoughts, with your issues, and we'll discuss them. Maybe it's formal, maybe it's informal. Just kind of depends on what you're trying to get here. A formal review might be where, okay, we are all satisfied with the requirements. Let's put our little green check mark in the system, move on to implementation or something of that nature. We could also prototype things. So maybe we're going to be developing our requirements alongside our prototypes. We build a shiny new prototype. Prototype has 3 or 4 brand new features. Well, let's backfill some requirements to support that. Let's link those requirements to test cases, to design decisions. Again, we're going to try to link everything together. When we get into test-driven development, this is again where you basically write test cases first and code later. You could do something similar with requirements. Let's develop some test cases that we're going to pass. Say we want to have a test case that ensures that a particular set of fields on a web form are validated appropriately, right? Email address has a certain format, password has certain complexity. You have 20 more fields specific to this application. Okay, our test cases will make sure these all pass. But we don't have requirements for this stuff yet. Well, let's add that in based on this prototype or these test cases that we're creating. Basically, you can develop requirements and validate them in multiple ways is kind of the takeaway here. Now, some of you not all of you, I'm going to assume, probably have heard the terms verification and validation before. V and V, if you have ever interned anywhere. Basically, this is kind of a weird statement to make, but if you're validating, it's checking that you're building the right thing. Verification, that you're building the thing right. And these two terms, they're kind of difficult to really define, but validation would be that you have something and you're testing it in a real world situation. Okay, so you have built the product, you have your test cases, your requirements, all that fun stuff. Now let's actually test it in a real world scenario. In a real world could be on a bench being fed input data or something like that. Verification, on the other hand, is more before you go out into the real world. It's going to be like mathematical proofs of does your program execute correctly? Or it could be, requirements verification where you go through a rigorous formal process to make sure that you've written everything correctly. The way, there's going to be different takes on what these mean as well, person to person. I'm more of a validation person. I like testing in real world scenarios, whereas other engineers, other researchers like verification, where it's more mathematically grounded. Maybe you're using simulations, things of that nature to actually, I'm kind of talking about actual hardware in front of you, right? Um, not strictly requirements, but the principles can apply to any artifact. You can be doing this for your models. You can be doing it for your requirements, for your code. Again, these are all just kind of artifacts that we have to verify and validate. Hopefully that's not too out of the realm of possibility there for you. Okay, so this has all been the requirements engineering process. Okay, now we're going to talk about management a little bit. Now, requirements management is very, very similar to how we manage projects and how we manage code. Requirements will be version controlled, they'll be checked in, they will have statuses attached to them, and we'll have traceability features as well. So again, this is not strictly a simple document. It's going to be a tool or a system of some kind that you put requirements into fields, and then you link them up to other objects in your system. And it sounds like an organizational nightmare because I'm describing these requirement specs as, 100, 200 page documents, probably minimum. Yours are going to be a lot smaller, don't worry. But the benefits kind of do creep in as you go through the software engineering process. Right? A little bit of extra overhead, yes, but the benefits you get are wonderful for this. As much as I despise it, I'm trying to remember if I have a let me see if I can pull up a quick image. I thought I had this, but I don't. Telelogic doors. Here we go. So this is one of the many systems that are out there. And let's see if I can get a decent image here. No, I guess that's as good as it is. So hopefully we can all see this. This used to be the bane of my existence when I was working in industry, but I can see the benefit. So this is one of the requirements engineering tools that are out there. And here you kind of see like 2.3.8.1.2 visibility, daylight, nighttime. So obviously this is for a vehicle. But every single requirement is basically an entity in the system. And it's very, very blurry. I apologize for that, but you see different data types. You see max min values, you see names, we see attributes. So basically, we can have a lot of very detailed information entered in for our requirements. So when I say they're an artifact, they're actually an entity that we can work with, entities with properties, possibly with methods that we can call. Effectively, they are living objects in our systems. Now you might say that, again, that sounds awful. Why would we do that? Well, you have the intern put them all in, right? But again, consider from a software engineering perspective, at some point, you're going to have to prove that every single requirement has been covered, that it has been tested, that it is linked to some code. This is what a requirements management tool gets you, right? You can actually see these links without having to do a massive process of proving it out to, say, an external auditor who's giving you a certification. we can also use this for change control. So we talked about change control in terms of software, works with requirements too. Let's say that you come in as the new hotshot developer on the team and you have all these wonderful ideas about how to make things better. Well, that's great, but that's going to add on an extra year of development time. We can basically have, revision control as part of a requirements engineering process. Maybe we tag these requirements changes as future additions, or we have people in charge of managing requirements and they say, no, we can't do this. That's going to be part of this actual system. Now you can make a change request. You could do an actual impact analysis. So let's say we want to update a bunch of requirements. What will that do to the rest of them? We can have people that have access rights to the system that can actually reject these update requests. We can actually do the updates, but maybe also, measure how volatile our requirements are with the system. And volatility would basically be how flexible or inflexible the requirements are. We can measure, how much has changed over time. Are they set in stone? And we can actually get very detailed metrics that are useful for our engineering processes. All right, where do we want to go now? Hopefully that all makes sense to you all. Any questions on why we would need a version control system for requirements? Steps off camera subtly as his nose is running. All making sense so far, I guess? I think so. Okay. If there's anything you need to take away from requirements, again, the important thing is going to be understanding how to write them. That's what your next homework assignment is going to help you with. But just be aware that the entire requirements engineering process is that a process, right? We have processes for software engineering, we have processes for testing, we also have processes for writing requirements. And what I'm at least trying to expose you to here is if you're interested in structuring a project, going the requirements analyst route might not be a bad path for you if this is something that you like. And if you hate it, you know how to stay far, you know what to stay far away from in industry. Okay, so let's talk about traceability and then we'll end for the day. So traceability is again that thing I'm talking about where we link all of our artifacts together. And artifacts, I'm going to say this again, any object that we create, whether it is a document, whether it is a requirement, a test case, a business rule, a use case, some kind of a UML diagram, anything can be entered into a system and traced. What's in class assignment 4? Oh, we're not going to get there. We're not going to get to that today. Don't worry about it. We'll get to it on Friday because you're not going to have enough time for this. I forget I wanted to do that today. Basically, we'll start with this on Friday, so don't worry. I'll update the deadline for that. For some reason, I was thinking we were going to end at like 9:40, 9:30, and we'd have time for an assignment, but we'll do that Friday. Let me make sure I write that down so that I don't forget. That is not what I wanted to pop up. Come on. Notepad, thank you. Update IC4. Okay. So traceability. A traceability matrix is something that sounds way cooler than it actually is. Basically, it's just a Excel sheet of what is linked to what. Okay, so here you've got a sample traceability matrix for requirements where we're going to link them to test cases. So this is a kind of a feature-rich type of a system here. On the row side, we have a bunch of test cases. On the column side, we have requirements. Okay, so we have requirements, we have test cases. Here are all the defects we have found. And just by looking at something like this, we can see which test cases are failing, right? So here, test case 6, pending, failed, passed, pending. You can kind of see exactly where the issues are very quickly, right? You as a, say, project manager or tester, whatever your role is. Okay, well, if I look at, say, this requirement here, requirement 8, I've got a test case failure here, test case 3, test case 6 also fails. What does this mean? Is there an issue with the implementation? Is there an issue with the test case? Is there an issue with the requirement? By looking at something like this, we can very quickly see maybe it's a one-off, maybe it's a common pattern. If it's a common pattern, maybe it's an issue with the requirement. You know, if you look at something over here like this requirement 29, there are a lot of failures. Why is that? Well, by knowing exactly which requirement we're testing, which test cases specifically are causing the issue, we can very, very quickly drill down into what the actual problem is. So you would have a matrix kind of like this for all of your artifacts. And this is a visualization, obviously. You would basically just have links in your system. So like requirement 1 would have a pointer to test cases 1 through n, which would have pointers to code lines 50 and test.c and so on and so forth. You can go overboard with this stuff too, I should mention as well. But the nice thing is that you can very easily look things up. All right, we do have some risks in software engineering too. Yeah, so we'll end here. I'll show you the in-class assignment, and that will be done for the day. Everything that I am talking about here so far really has been kind of an ideal scenario, right? Everybody's going to get on board together. Everybody's going to work together to have a successful project. We are going to have no issues, no scope creep. Everything's going to be beautiful, right? That's never going to be the case. Software engineering is all about, again, trade-offs and managing risk and how you handle things. So what are some common things that you can expect to see? Insufficient or no user involvement or customer involvement. Basically meaning that you're creating a product and you never get feedback from your customer. What's that going to lead to? Probably something the customer doesn't want. That is a risk that you manage. How do you manage that? Force your customer to talk to you, right? Track them down and set up meetings and things of that nature. Maybe you forget about some different types of users that are actually going to be using your system. You develop a wonderful mobile app for the masses, but then you only developed it for Android, so you left off all those Windows Phone users that are clamoring for applications. He said, really missing the Metro interface. Maybe requirements are vague or ambiguous. Then your team doesn't know what to build. Maybe you add something that nobody uses. Okay, so let's talk about games that are online only and people who have spotty or bad internet now can't play your game. We have analysis paralysis, which is a buzzwordy term that I absolutely hate, but it makes sense. We spend so much time analyzing, we spend so much time going through our artifacts, making sure that everything is linked up appropriately. We never actually build the product. So we can spend way too much time basically in meetings. We can have scope creep. This is a great one for you all to be aware of. Okay, so honestly, in terms of risks, let's talk about your term projects very briefly. Scope creep and team building are going to be your two biggest challenges, especially in this online only setting. Hey, let's add multiplayer. Hey, let's take this 2D game that we're talking about and make it 3D. Hey, let's design all of our own art assets. Okay, these are all things that sound great, and then you actually look to go ahead and do it and realize it's going to take you way longer than it needs to. Or insufficient involvement, maybe you have team members who are not contributing, maybe you have team members who are butting heads because they have different ideas. These are going to be things that you're going to have to resolve nicely. And what you're getting at here in class is exactly what's going to happen in the real world, just in a smaller scope, honestly. So just be aware, these are all things that we have to deal with. Last but not least, this is what we'll start off with on Friday. I'm going to have you break out into teams, and this is not going to be your project teams, it will be just your Discord channel teams. but I'm going to be looking for 2 functional and 2 non-functional goals for a web application. Requirements, sorry, not goals. So that is where we'll start on Friday. Any lingering questions at all? Or are we all good? Alrighty. Well, any questions, feel free to pop them into chat or into Discord or into email, whatever your preferred method of contacting me is for after class. Okay. Well, class is officially over, so if you want, do you want to pop by office hours or talk to me in Discord? Let's stop recording.